All right, hello everyone, this is Mr. Crozier. I'm going to go over graph worksheet number 4. We start off with this equation. P of W is equal to negative 0.6 W to the third. So there it is. I put it all in with X's and Y's. For my window, I'm going for 0 to 7 because it's a 7-week domain. And I've already done it. 40 is fine. So there's my graph. Price goes down, price goes up. I can trace it. At any point in time, I know the price of the stock. All right, so let's go ahead and ask some questions. Number one, relative minimums. Well, that's going to be that value there. And again, how do we do minimums? Well, we could trace it, and we could get very close to a minimum, which is right about there, 0.741, 6.75. So we could have that minimum there. However, a better way to do it is to do the actual minimum calculation. So I'm going to hit second calc, and I'm going to do the minimum, and it's a 3-step process. Left side of the minimum, right side of the minimum, and make a guess. Your calculator will take that and it will calculate it accurately so you can use those numbers. So you want to use those features right there. P of 3. Well, what's the price at 3? Again, if you want to trace it, you can trace it over to 3, which is about right there, about $21. However, it's better to go to the home screen, pull up the variables, Y1, and I'm going to input 3, $21.40. Relative maximum, well, that's this point up here. Do the same logic we did up there, those same steps. Continuous and differentiable. It is continuous, it is differentiable. Increasing intervals, well, it's going up from this point in time to this point in time. All of this is an up direction. And then we have a down arrow here and a down arrow there. So we have decreasing, increasing, decreasing. Initial price of the stock, well, that means what is the first price? Variable, well, what is the price at time 0? $9.40. Maximum price, well, hey, we already did that up there. There's that maximum value, 38.28. It's right there at a maximum. The derivatives value, now look what I'm going to do here. I'm going to put in here for y2, I'm going to make this do the derivative. Math 8 ddx of the first function. And I'm going to have it across all x values. So this equation now, y2 is now taking the derivative of the first one. I let the calculator do the derivatives. All right, so let me go back to here, y variable, and I'm going to plug in 3. 9.99, which rounds up to $10. $10 per week. Now what's the second derivative? The concavity. Well, I'm going to make another derivative here. ddx of y2. There you go. So now what I've done here is I have this equation's taking the derivative of this one, and this one's taking the derivative of this one, which is the derivative of this one. Function, first derivative, second derivative. Position, velocity, acceleration. And notice I unhighlighted these graphs. If you click on the equal sign, it will graph that, but it takes a long time to graph it. So I'd go ahead and turn those off because I don't need the graphs of those now. All right, a second derivative value. Y3, plug in 3, and there it is, 40 cents per week. It's slowing down by 40 cents per week. It's still going up, but it's 40 cents per week. Average rate of change. Well, 5 minus 2 is 3. And average rate of change, one way you can do this on your calculator is just go, I'm going to do it all in one step right here. There we go. Whoops, I need that to be a 2. That is that value there. That's the change in price from week 5 to week 2. That's 3 weeks, $8.40 per week. Whoops, forgot to divide it by 3. There we go, 8.4. The range. That would be the lowest price to the highest price. That's the lowest the stock was. That's the highest the stock was. When does the minimum occur? Well, right there. Hey, we already have that number here. You're going to have a lot of these same numbers repeating. That's when the minimum occurs. That is the minimum. Points of inflection. This is just an estimation. You look for a point where the concavity changes, and I guess this point right there. Because what I see here is this right side is concave down, and this left side is concave up. And there's that change in concavity, and it occurs right there at that value. And you just have to estimate. We're not going to do the math to figure out this one. We're just going to pick a point. And you can you can do that by hitting graph. You can hit trace. You could go over and estimate where it is. When was the price of the stock? 35. Well, let's go ahead and put this in here. How about a new equation? $35. Graph it. There it is. There are 2 points in time. Week 4 and week 6. And how do I get those? Well, I could trace them. Again, I could trace and get very close to that point of intersection, but I need to do a second calc, and I'm going to do intersect. And I'm going to ask for the first curve. There it is, the blue one. Second curve. There it is. Press enter. And now it asks for a guess. So now I go over and press enter. It is a 3-step process. First, second, and make your guess. And there's the intersection. At week 4.526, the price is 35. Repeat the process over there. Number 5, instantaneous rate of change. That simply means slope. Let's clear this out. Second, or variables. I think that second one was my derivative, and I wanted it at 3.6. Identify zeros. When is the price 0? When, this is what a 0 looks like. What input gives me an output of 0? Well, the stock never goes to 0. When was the price less than $20? So I'm going to change this 35 to 20. And there's my graph of my stock. There's that value. And at this point in time, to the left, from about 2.8 to the left, all of this area here is underneath the curve. So it's from 0, and I put a closed bracket there, 0 to 2.859. And when is the derivative 0? Well, those are our critical points right there and there. At those 2 points in time, the derivative is 0. All right, hope this helps with your assignment.